Okay, hello. My name is Muhammad SYAWAL bin ZAINAL KARIB. I am from Group AW together with KHAIRUL HAREEQ and Muhammad AIMAN SYAZWAN. So we need to explain about the demonstration of the learning outcome for machine learning. Basically, we have 5 tutorials that we need to explain in this video. So for the first tutorial one, I will be in charge of it. So here is the week 5 tutorial question 1 uh, that I have to explain about the intuition behind the cost function indicate as a j of theta 0, theta 1 equal to 1 over 2m summation of m multiplied by hash note of input of subscript I minus by output subscript I squared. So here we have two types of y, basically the y and the hash note. Basically, y is indicate for the data output data set, while hash note indicate for the hypothesis data. Hypothesis data is used to represent the hash note here. Is used to represent the supervised learning as general. When after we identify the training data set in terms of x and y, the problem we will deal uh, we will have the hypothesis data after that. So from here, the learning outcome algorithm, the prediction of data set is in hypothesis through the input of data set denoted as x. So for the output of hypothesis here, is displayed as a y. So the term of the hypothesis itself has been identified as the hypothesis in the world machine learning. So from here, what I can explain about the two graph in the tutorial question 1. It shows us that there are 3 input and 3 output data set located at this point here, 1, 2, 3, indicate as the hash note of x. Let's say if we want to get the hash note of x in the value of the q1 that given as 0.5, so we can draw the straight line here based on the input dataset that given in this slide. So graphically, we can see the difference between the hash note with the input dataset. So if we do the cost function, the value, the new value of the cost function itself will equivalent to 0.58, where we just substitute the value here into the equation above, and we will get the 0.58 and the graphic. So the graphically we can see that we can plot the new value, the new point to this function of the parameter of q1, indicate as a graph of j theta 1. So that is from me for the tutorial question 1. I will proceed to the next tutorial, week 5 tutorial question 2. So we have 3 slides here, the gradient descent and the gradient descent 2 and the choosing alpha or learning rate alpha. So what is the gradient descent? Okay, the gradient descent basically indicate as what you call is an optimization algorithm which is mainly used to find the minimum of a function. So from here, we can see that there is a 2 figure indicate as h naught x and j of theta naught and theta 1. So the example show that the gradient descent successfully converge and minimum value of the cost function j is obtained, shown in these 2 figure. So how it's successfully converge? So we have to contour plot at the right side, and the graph of with the hypothesis line at the left side. So when the value of the theta naught and theta 1 is somewhere around here, the hypothesis line is drawn here. So it is very far from the fitting out of the training data in the next figure. So the data is a bit closer to the center of the contour plot, which is located here. The line is still somewhere around here, so it is still unfit to the training data. So it's still unfit. So the gradient descent will change the Q closer to the contour at the plot. So the line is quite fit. So after we alter, basically if we take the line in the control plot here, we will see that the line of the data set will quite fit when the J function is now located at the center of the control point here. So that's how the gradient descent converge. And from the choosing alpha or the learning rate is the other important gradient descent that we must analyze. So by having a small alpha, it will take a small change of the value that can be seen that the movement of the converge is slow. So therefore, it will slow down the movement or slow down the process to get the minimum value of J. Meanwhile, if the alpha is too huge, um, it will affect the process to get the value of J, where it may overshoot at the minimum and probably will fail to converge. And mostly case, it may not diverge at all. So it is important to get the learning rate at the optimum value. So the process to get the J will be in the optimum process. So that's why it is important to get a better learning rate or indicate as alpha. So that is from me for tutorial question 2. Thank you.
Good evening, my name is KHAIRUL. Today I will explain about the delineation and the scientific gradation of pharmaceutical species. So this is the command to obtain the semantic update. For theta 0, theta 1, theta 2, example of different features. Feature scaling for gradient example, we need to do feature scaling because if the range or value of each feature are too widely different, so we cannot proceed with the gradient because the graph we obtain will not obtain the more accurate graph. For example, the size may vary from 100 square feet to 1000 square feet, and number of value may vary until 1 to 5. So we need to do feature scaling method. There are 3 feature scaling methods. Which is method number 1. If we set the range from 0 until 1 using simple formula. Feature scaling number 2, by get every feature into approximately a -1 until 1 range. And feature scaling number 3, by mean normalization by replacing Si with Si minus mu I to make features approximately 0 means. So for example, if I choose the size of 1500 minus 1000 will be divided by 2000, we will obtain the value of 0.25. And for the second example, if we choose the number, for example, 5 minus 2 divided by 5, we obtain the value of 0.6. So 0.5 and 0.6 is still within the range of 0 and 1. It depends on the designer to choose its range for each feature. That's all from me. Thank you.
Hello, my name is AIMAN SYAZWAN bin SHABRI. My method number AB 0217100052. Okay, today I would like to explain about a cost function in a regression. Okay, cost function can be set to identify the best fit feature parameter to reduce the underfit or overfit. Okay, you can see here the cost function, linear regression cost function has been given by this equation, and there are two type logic regression cost function, which are negative log h to the x, which y is equal to 1, and negative log 1 minus h to the x if a y 0 to. There are two types here. Okay, we go to see the first one. Okay, the first one is given if y equal to 1. Okay, if a y equal to 1, the cost equal to 0 is prediction is correct. Okay, as a position opposite, hx equal to 0, and then the cost will be infinity right here. Okay, and the capture intuition of hx equal to 0 but y is equal to 1, we can penalize the learning algorithm is very large cost. Okay, to see the comparison of the disk function, we go to the next situation, which we assume that y is equal to 0. Okay, if y equal to 0, the cost is 0 if prediction is correct. Okay, as in the opposite one, where y minus h to the x equal to 1, and then the cost will be infinity. It is the line of the graph. We can capture the intuition. The larger mistake should be larger penalties. All right, and then we can see the simply cost function when y equal to 1, y equal to 0. Therefore, the generalized cost function can be writing as below: cos h to the x and y equal to what negative y log h to the x minus 1 minus y log 1 minus h to the x. Okay, this is a generalized cost function after we simplify the cost function. Okay, next slide, I want to explain about intuition cost function. Okay, we see the first one in the left is which theta 0 plus theta 1s plus theta 2s2. Okay, this feature has only a few features, and the side of house with the price, we can see the graph is underfit. We call the high bias. So this means when the less the parameter of the feature can make the graph in underfit. By the way, if the feature is more than 3 or 4, we can see theta 0, theta 1s, theta 2s equals 2, and the theta 3 and theta 4. So the graph will be overfit. We can see the graph, the dot graph is overfit. Okay, so to make the we have to reduce the feature. We can draw the equation like this, which are summation m h to the s. We do a plus with the 1000 theta 3 and plus 1000 theta 3. This equation is used to make the theta 3 and theta 4 almost to the 0 or equal to 0, so that we can make the graph is nice, which is underfit. Okay, to find more about underfit, overfit, or just nice, we can see here theta 0 plus theta 1 is underfit, high bias, and the line of in the graph is linear straight upward. Okay, to see the second one is theta 0, theta 1, and up to the theta 2. The graph is called nice, but when the added with the theta 3 and theta 4, it come overfit. There are too many features, and this will come overfit. We can see right here. So there are two ways to reduce the parameter or the feature, which is we make the theta 3 and theta 4 equal to almost to the 0, and then we can find the underfit graph. Or we can use a cost function just now in the previous slide to make the parameter and feature have a graph nice for selection. Okay, that's all from me. Thank you.